Hey guys, what's up? Welcome to lesson 38. We're going to add and subtract decimal numbers and whole numbers. First off, a couple of ways to write $3 and 3. I mean, we've all seen this before, $3. You can write 3, like this, $3 with the cents there, so we all know that. If you ever have a choice, write that. It takes less time and, less space. The numeral 3, you can write like this. Of course, you could, if you want to, you could write 3.0. It's the same thing, right? You could add another 0. You could add another 0, but that's all you could. No, I'm just kidding. You could add as many zeros as you want. 74 zeros, for example, as I'm going to do right now. No, I'm not going to do that. Okay, it takes too much time. So that's two ways to write the same thing. That starts us with what we're going to do today. Adding numbers, one of them is a whole number, an integer, and one of them is a decimal number. Now all you need to do is visualize the 12 as having a decimal point. So, you can do this in any order you want. You could do 7.5 on top or the 12 on top, whatever. Let's just do the 7.5 on top. If you visualize the 12, you visualize it as having a decimal. So you write the, nice and neat in order, and then point, and you can put a 0 there. You can put nothing there. It doesn't really matter. I think most of us would probably want to see that 0. Somehow it's just comforting to see zeros all around us, no matter where we are. Helps us sleep better. Okay. 5 plus 0 is 5. 7 plus 2 is 9. 1 plus nothing is... What is 1 plus nothing? What is 1 plus 0? 1. Okay, it's 1. There it is. Okay. Got it. Okay, let's try another one. Subtract this time. 12.75 minus, and then 5. Well, just, line up the 5 so that you're saying, oh, this is 5 point, and then you can be done. Or you can write a couple of zeros to make it nice for yourself. Excuse me. 7.75 is going to be our answer. Piece of cake. There we go. All right. Now let's talk about squares and square roots. You've probably heard of these before. Let's talk about it. Squaring a number is just a quick way of saying you're going to multiply the number by itself. All right. So, you could look at a picture and go, if somebody says to you, what's 3 squared? Well, let's pretend this is a, I don't know. It's a giant, this is your prison cell. It is 3, and you're going to square it by multiplying by itself, right? So you can look at this and go, well, this is 3 on one side and 3 on the other side. You're going to have 9 squares, right? So let's say your bed will be this right there. There's a little shelf for you to put all your books on, your Saxon books and everything like that. And of course, maybe in the corner, there is a little place you can, what, never mind. Okay, anyway, no, we don't need this thing. Okay. To square a number, if somebody says 3 squared, instead of having to write 3 times 3, or 3 times 3, there's a little indication we can put on there that's just a little 2. Now the 2, remember, we talked about like, oh, something is 10 inches long. That just means it's 10 inches long. But if somebody says, oh, this is 10 square inches, you put a little 2 there, that tells the person, this is an area, not just a one dimension. It's 2 dimensions. That's why we call it square feet or whatever. So if somebody says that's 10 square inches, the person goes, oh yeah, that's going to be 10 squares. It'll be 2 on this side, let's say, for example. That's going to be 10 square inches, assuming those are squares, which they're not. Anyway, 3 squared is just a kind of a shorthand way of writing 3 times 3. Because you don't want to have to always write 3 times 3. Just write, somebody says 3 squared, boom. If somebody says 10 squared, you know what that means. 10 times 10, and the person will write something like this, 10 squared. There you go. Okay, what is 12 squared? Two examples of this. Well, 12 squared is the same thing as saying 12 times 12, so that'll be 144. I hope you know that times table. All right. Simplify 3 squared plus 4 squared. Well, piece of cake. 3 squared is 3 times 3, or 9. 4 squared is the same thing as 16. So all you need to do here is just add 9 plus 16, and the answer is 25. Now here's something funny. 3 squared plus 4 squared is 25. Well, 25 is what number squared? It's 5 squared, right? There's something in geometry, we'll talk about that later on, that shows an example of 3 squared plus 4 squared is 5 squared. Very interesting. Okay, what is the area of a square with sides 8 inches long? Now you can draw this if you want, if you're a visual learner. You can lean forward and sniff the screen if you're a nasal learner. Or you can just think about it. Okay, the area of a square, the sides are 8 inches long. Well, if one side's 8 inches long, that means all the sides are 8 inches long, right? So you can just say it's 8 by 8. That's going to be 8 squared, or 64. Now make sure when you write the answer, you don't just write 64. Really, it's not that big of a deal. I mean, but Saxon does like you to write the answer with the unit. So write 64, not inches, that's a length. This is an area, so you write a little boop, 2 right there to indicate that there's 2 dimensions. It's not just, 64 inches long. It's 64 square inches, which means there are 64 little squares in that entire figure. There you go. Okay. All right. How do you find a square's side length given its area? Let's say somebody says to you, a square's area is 25, square inches. And the person says, well, how long, what's the square's side length? Well, it's going to be 5, right? Because it's going to be 5 by 5 is 25 square inches. There you go. If somebody says to you a square's area is 100 square inches, well, that means the square root of 100. In other words, it's going to be 10 by 10. 10 times 10 is 100, so the side length of that square is 10. Now, the square root symbol is this. That's what it looks like. Probably seen it before. So if you say something like, there's 100 underneath there. Now there's a number that's assumed to be right here. It's a 2. But if you don't see a number there, that just means it's the square root. Now eventually we'll get into cube roots and all kinds of things like that. And that's for another day. But there won't be a number there usually. The square root of 100, that's how you read that. Well, that means what number times itself gives you 100, which is 10. Now don't get mistaken and go, it's 50. That's half of 100. No, 50 times 50 is 2,500, so the answer is not 50. So you need a number that multiplied by itself gives you this number. That's how the question is going to be done. Now, perfect squares, those are numbers that have been, that you can take a perfect square root of and get an integer as a number. In other words, 1 is a perfect square because it's 1 times 1. 4 is a perfect square because it's 2 times 2. 9 is 3 times 3. 16 is 4 times 4. 729, of course, is 27 times 27. 6,561 is, of course, 81. You remember? No. Fractions are division. Okay. Never mind. Okay. Well, let's try a few of these. Simplify this. The square root of 64 is how you read this. Well, the answer is what number times itself gives you 64, and the answer, of course, is 8. There it is. All right, try another one. Let's try a lot of these. Okay, I've busted these up into 2 chunks. So for the practice set, it's on page 200. Whoa, how about that? 200 pages we've done. Awesome. Okay, go ahead and do, let's see, the first half. All right, the first half, however many that is. A, B, C, D, E, F, G, H, I, J, K. Do the first half and stop there and then unpause it. Pause it right now and do those. Okay, I'm assuming you pause it. Let's take a look at A through H and adding right down 6.1, 3.4, and make sure on C that you get exactly, look at this. I'm reading this wrong. B is going across, my bad. 3 plus 0.4, boom, boom. Okay, D, 42.7. That should be a, you know what? That's wrong. D is wrong. Let me fix D. That's 43.2 minus 5. That should be 38.2. My bad. Okay. E, 0.23 plus 4 plus 3.7. 0.23 plus 4 plus 3.7. Ooh, I goofed that one up too. 3.7. That should be more than that. Should I do all these? Good grief. Okay, so 7, that's 0.93. That's going to be 7.93. Ignore E. Okay. F is 6.3 minus 6. There's, boom, I got that one right at least. G is pretty clear. 75.25 minus 25 is 50.25. Okay, now go ahead and pause it and do the rest of them. Okay, let's take a look and let's see if I actually got these right or not. All right, I, of course, 9 squared is 9 times 9, 81. J, the answer to that is 9. So there was almost like the opposite of each other, the whole problem. 6 squared is 36. 8 squared is 64. Those added together give you 100, excuse me. The square root of 100 is 10 for L. Minus 7, which is the square root of 49, is 3. So that's L. All right. 15 squared means 15 times 15. You probably had to write this down and do it. That's fine. 225. The square root of 144 is 12. O is, let's see, 6 feet times 6 feet. Now make sure you have that little 2 here. Don't just put 36 feet, because 6 feet, times 6 feet means this. 6 feet that way, and then 6 feet that way, which will give you 36 little squares in that. That's a two-dimensional object. All right. P, 64, and the square root of 64 is 8. The square root of m to the second just to be 8 meters, right? All right. Let's take a look at Q. Starting with 1, the first 4 perfect squares are as follows. What are the next 4 perfect squares? Well, in other words, 1 times 1 is 1. 2 times 2 is 4, and so on. That gives you 4 and 9, 16. The next one will be 5 squared is 25. So it would be 36. Then 49, 7 times 7. Then 8 times 8, 64. There you go. Okay. All right. Well, that's it for the squares. Have a great time with those today, and see you guys next time. Take care.